Imagine a judge ordering the immediate, irreversible deletion of a $300 million artificial intelligence model. No patches, no updates, just complete digital annihilation. This is no longer a hypothetical nightmare. In July 2026, the era of fair use excuses is dead. If an AI company cannot mathematically prove where every single pixel and word of its training data came from, their entire neural network is legally classified as stolen goods. To understand why the industry is panicking, we have to dismantle the most pervasive myth in modern technology. For years, AI labs told us that neural networks learn just like human brains. They claim their models read books and look at images, digest the concepts, and create something entirely new. But that is where everyone is wrong. Computer scientists are increasingly proving that deep learning models do not think. They compress. A landmark 2024 study proposed a radical but accurate framing. Training a foundation model is mathematically identical to data compression. Think of a model weight matrix not as an artificial mind, but as a highly sophisticated, lossy zip file. When an AI company feeds millions of copyrighted novels or digital paintings into a network, the resulting weights are actually storing compressed, high-dimensional mathematical representations of that exact data. If you prompt the model, you are simply decompressing those stored files. This technical shift changed everything in the eyes of the law. If a model weight is just a compressed copy of a copyrighted work, then training a model on unlicensed data is not learning. It is infringement. And the penalty for hosting infringing files is simple: destruction. When courts first began ordering companies to clean up their models, developers assumed they could just use quick fixes. The most popular proposal was machine unlearning, a process designed to make a neural network forget specific data points after it had already been trained. But the research shows these post hoc patches are a mathematical illusion. Imagine trying to remove a single, specific raw egg from a cake that has already been baked and iced. During the training process, a process called backpropagation distributes the features of a single image or paragraph across billions of interconnected mathematical parameters. The data is baked into the very fabric of the network. If you try to surgically zero out those specific weights, the entire model degrades. It gets dumber, less coherent, and prone to breaking. Other techniques, like differential privacy, try to add mathematical noise to hide the training data, but they often ruin the model utility for complex enterprise tasks. The industry was backed into a corner. You cannot reliably unlearn. You cannot safely hide the data. The only way to survive a compliance audit is to ensure that not a single unauthorized molecule of data ever enters the oven in the first place. This is where we need a completely new way of verifying digital reality. To understand how engineers solve this, we have to look at how global pharmaceutical companies handle raw ingredients. If a drug company manufactures a life-saving medicine, they do not just throw random chemicals into a vat and hope for the best. Every single gram of active ingredient is tracked from its source farm or chemical lab. It is sealed in physical containers with tamper-proof locks, logged on a secure custody chain, and verified at every step of shipping. If one batch of raw material is found to be contaminated, the company does not have to burn down their entire warehouse. They look at the ledger, locate the exact serial numbers, and pull only those specific bottles. In the digital world, AI developers are now building the exact same safety mechanism. They call it a data provenance certificate. Instead of physical cargo containers, they use cryptographic hashes. Instead of a paper custody chain, they use decentralized, immutable ledgers. This certificate is a mathematical receipt that links the raw training asset directly to the final trained weight, proving beyond a shadow of doubt that every single digital ingredient was licensed, consented to, and clean. So, how does a data provenance certificate actually function under the hood? It begins long before the supercomputers start spinning up. When a dataset is curated, every individual file is put through a cryptographic hashing algorithm, typically SHA-256. This creates a unique 64-character digital fingerprint of the data. If even a single character in a 10-gigabit text file is altered, the resulting hash completely changes. These fingerprints are then organized into a hierarchical data structure called a Merkle tree. This allows billions of file hashes to be summarized into a single master root hash. During the training process, The engineering pipeline binds this root hash to the model training run itself. As the neural network processes each batch of data, a decentralized ledger records a secure timestamp of the ingestion event. When the final weight checkpoint is generated, the model weights are cryptographically signed alongside the dataset root hash. This creates an unbroken, mathematical chain of custody. If a regulator demands proof of compliance, the developer does not have to hand over a messy pile of hard drives. They present the root hash and the cryptographic signature, proving the model was built exclusively on the certified dataset. But this architecture faces a major commercial bottleneck. AI companies are intensely secretive. Their training datasets are their most valuable trade secrets, and they cannot simply publish them for the world to see. At the same time, creators want to verify their intellectual property was not stolen, and regulators want to audit the systems. How do you prove you have nothing to hide without showing what you have? The answer lies in zero-knowledge proofs and public ledger verification. Instead of exposing the raw training data, AI developers publish only the cryptographic root hashes to an immutable, decentralized ledger. This ledger is public, transparent, and impossible to retroactively alter. When an artist wants to check if their portfolio was used to train a model, they do not search the model code. They hash their own original files locally on their computer. They then query the public ledger to see if their file fingerprint exists within the certified Merkle tree of that model. If there is no match, the developer is mathematically cleared. If there is a match, the developer must show they had a valid license for that specific hash. It is a system of absolute verification that protects both the intellectual property of the creator and the trade secrets of the developer. This technical shift is creating a massive economic divide in the tech sector. The market has split into two distinct categories: clean source models and toxic legacy models. Before 2026, companies rushed to deploy the largest models possible, regardless of where the data came from. But today, enterprise legal departments are refusing to touch unverified networks. A model trained on scraped, uncertified web data is a ticking legal time bomb. If a court orders that model destroyed, any enterprise application built on top of it instantly vanishes. As a result, the value of uncertified models is collapsing to zero. Meanwhile, certified models with clean data provenance certificates are commanding a massive premium. Companies like Adobe, Shutterstock, and major media conglomerates are leveraging their massive, clean archives to train highly valuable, legally defensible models. For the first time, clean data is not just an ethical preference, it is a hard business requirement. We are witnessing the end of the digital gold rush and the beginning of the era of cryptographic truth. The myth of the magic black box has been shattered. By treating neural networks as what they actually are, complex mathematical compression engines, we have finally found a way to bridge the gap between creative ownership and technological progress. Data provenance certificates do not restrict innovation. They provide the secure, stable foundation that innovation needs to survive. In a world increasingly flooded with synthetic content and automated decisions, the most valuable asset is no longer raw processing power. It is the mathematical certainty of where our information actually comes from.